Amplitude modulation, AM. So the basic definition is if the amplitude of the carrier wave changes in accordance with the intensity of the modulating signal, then it is called amplitude modulation. So here we represent the carrier wave C of t is equal to AC, amplitude of the carrier, cos 2 pi fct. This is the frequency of the carrier. Now m of t is the modulating signal or baseband signal that is going to modulate this carrier. Now if you carefully watch this m of t, that is this AC into 1 plus Ka m of t, this entire thing forms the amplitude of the carrier. That means if the modulating signal m of t or baseband signal varies, this amplitude is going to vary but not the frequency. That's why it is called amplitude modulation. So C of t is the representation of the carrier wave and S of t is the modulated signal. That is this m of t tries to modify the amplitude of the carrier and therefore we will get an amplitude modulated signal. So these two waveforms are represented in time domain. Now Ka is a constant called the amplitude sensitivity. Now we have two cases. Modulus or magnitude of Ka m of t, this value Ka m of t is less than 1 for all t, that is one case. And it can be the other case also. If modulus of Ka m of t greater than 1 for any t, then we call it as overmodulated and phase reversals will occur. So to show this, for example, so this is a modulating signal. So it has multiple frequencies. Say if it is going to be audio frequency 20 hertz to 20 kilohertz. So for a particular time interval, these are it is in time domain. It may have some range of frequencies. Now this modulating signal or baseband signal, we have two cases just now I told you. Modulus of Ka m of t, if it is less than 1. Now if you see this say baseband signal is above 0 and you can see the same baseband signal below the 0 also. That is positive side also you can see the waveform, negative side also you can see the waveform. Now this is the carrier. Actually between these two there is no continuity. To represent we are doing in dotted lines. So the carrier amplitude is changing now. There is no phase reversal. But just now I told you for overmodulated signal, modulus of Ka m of t is greater than 1. In this case what happens is, you can see the baseband signal, but whenever it crosses the 0, see the waveform goes like this, crosses 0. So this is the carrier wave. At the point of crossing the 0 level, you can see the phase reversal. See actually it has to go like this, but there is a phase reversal. And once again this waveform baseband signal crosses the 0. Therefore once again you can see the phase reversal. This is because modulus of Ka m of t or the magnitude of Ka m of t is greater than 1 and we call it as overmodulation. Overmodulated and phase reversals will occur. This is a problem. Another important point you have to remember in amplitude modulation is the carrier frequency which should be very much greater than the baseband frequency. For example, if you take audio frequency range, say 20 Hz to 20 kilohertz. So this is 20 kilohertz. Then the carrier frequency should be very much greater than 20 kilohertz. If you see the AM radio receiver, 300 kilohertz to 3000 kilohertz will be the range. So 300 kilohertz is very much greater than this 20 kilohertz. Suppose if you want to modulate a video signal, which is 5 megahertz, then the carrier can be roughly say 5 megahertz into 10, 50 megahertz, very much greater, 50 megahertz or 100 megahertz like that. So the one important point what you have to remember is, whatever may be the baseband signal, the carrier frequency should be very much greater than the baseband frequency. Now the next point is, this is the amplitude modulated signal in time domain. Now we are going to represent this in frequency domain. As such, the explanation of amplitude modulation is over. But we want to see what happens in the frequency domain. So this time domain amplitude modulated signal is converted in frequency domain using Fourier transform. So we are in Fourier domain now. So this S of t, when you take Fourier transform S of f, and you can see AC by 2 into del f minus fc plus del f plus fc. So here itself you can see two components plus KAAC by 2 into m f minus fc plus m f plus fc. Here again two components. Okay. So this is the representation of this time domain signal of AM in frequency domain using, that is, we call it as Fourier domain. Now we have to check out for the transmission bandwidth. The transmission bandwidth is twice the highest frequency in the particular range. For example, if 5 kilohertz is the highest frequency, you can have 1 kilohertz, 2 kilohertz, anything like that. But assume that in that spectrum only 5 kilohertz is the highest frequency. In that case, transmission bandwidth is, you just multiply this value by 2. That is, it is 10 kilohertz. If it is going to be 10 kilohertz, you multiply it, bandwidth will be 20 kilohertz. That's how you have to remember. So this is one case. Now this frequency domain representation of our amplitude modulated signal, I will show you. So spectrum of the baseband signal. So W is the maximum frequency of the baseband signal. So when you represent in Fourier domain, you will be representing like this, minus W2 plus W, x-axis frequency and y-axis is the m of f, and the center value which is 0 hertz, at that point it is maximum, which is m of 0. Now S of f means this is time domain that we have converted into frequency domain. I told you the representation is here, Fourier transform of that signal. So you can see at the mid, S of f, x-axis its frequency. Here we have fc. The same baseband signal we can see here as well as here. Here it is carrier frequency, upper side, we call it as upper sideband, and here we call it as lower sideband. So this is USB, upper sideband, USB, and this is lower sideband. So as such, we have all the frequencies in the upper sideband, information in the upper sideband as well as in the lower sideband. This is with respect to this point. Similarly, the same spectrum you can see at the left hand side also, which is minus Fc. This point is minus Fc plus W, and this is minus Fc minus W. Now this left hand side is upper sideband and this part is lower sideband. This is spectrum of AM wave. So now the amplitude, here the amplitude is AC by 2 del F minus Fc. Here again the amplitude is AC by 2 del F plus Fc. At the mid the amplitude is half Ka AC M of 0, because we have seen here Ka AC by 2 M into F minus Fc. The other one is Ka AC by 2 M into F plus Fc M. Okay. So that's all about amplitude modulation. Hope you have understood this topic on amplitude modulation. Thanks for watching this video. Nandri.